So I have the distinct honor of having the longest title of Practical Cartography Day, so sorry about that. But today I'm going to talk about how we make the labels work on our protection district maps, which are cartographic products that are the responsibility of myself and my colleague Chauncey Smith, who's also here at this conference. These maps are 1 to 100,000 scale maps that cover our 12 ODF districts throughout the state of Oregon. These maps are printed and used by ODF district staff, mostly firefighters and foresters. They're also sold to the public for recreational use. And then we create digital products for use in our web applications and mobile applications that some of our field staff use as well. This map is an internal map that we use to track the age of some of the protection district maps as we go through and update them, but it outlines where our districts lie throughout the state of Oregon, and then where the map sheets are. So it's 53 total map sheets throughout the state that cover about 74,000 square miles. In 2018, we moved these projects to ArcGIS Pro, mostly to take advantage of having multiple map layouts in a single APRX, because the next map that we were going to work on would end up being 6 separate map sheets, and we didn't really want to deal with 6 MXDs. But as we worked through a couple of these projects, we started to take advantage of the more advanced label engine. In the past, these projects used almost entirely annotation for labels, but we were really starting to take advantage of the label engine to actually draw labels from our data instead of using annotation. And there's kind of some things you have to weigh, whether you're going to use labels or annotation. You know, some of the cons and pros of labels. Labels update with your data, so as the underlying data is edited, those labels will update themselves next time you open the map. You can take advantage of the label engine's dynamic placement and formatting. Scale flexibility is a big one, so you can, annotation is built in a specific map scale, but if you're labeling from your data, you can use it in different scales. I mentioned that we create some tile layers that we use as base maps, and annotation are not compatible in those environments. And then updating our maps actually helps us improve our data rather than spending our time editing annotation and placing it. Annotation does have advantages, so you can put it right exactly where you want, and you don't have to worry about it bouncing around in weird places. It is a feature class, so you can use it to layer with other features on your map. It does have better performance, so the label engine can be slow, especially in these complicated maps, and then your data can be terrible, and it doesn't matter if your annotation is good. But we have, over the course of several projects, have moved to almost entirely using labels. But this can get complicated because these maps have a lot of things on them. Most of the complication for us comes from our roads and streams layers. That those are kind of the things that people want labeled the most, but there are a lot of other things that these labels are trying to interact with. And the next part of this talk, I'm going to go through some of the challenges that we run into using labels, and then some of the solutions that we've figured out to work around these. So one of the big ones is data quality. So inconsistent attributes in our data, we're labeling from these attributes. This is a snapshot of our roads layer, and there are 3 label fields that we use. There's official name, which is just the name of the road, an alternate name that is maybe something else that it's called, in this example, Highway 101 and Pacific Coast Highway, and then a road number field, which should only have numbers in it except for sometimes a prefix, which is used for a specific reason that I'll talk about in a little bit. So this is, in a perfect world, what we would have. It is not what we have in real life, because our roads data comes from a lot of different places. It's edited by a lot of different people, many of whom are not GIS people and do not care as much about data quality as we do. So we end up with things all over the map. These examples, if you can read them from where you're sitting, we've got names in the road number field, we've got alternate names that are the same as the official name. We've got inconsistent spelling and abbreviations, all which cause us lots of problems with that. So really the main solution for this, and what takes up a lot of our time now in these map updates, is just editing the data to make it, you know, a lot more consistent. But some of the other things that we can do is try to kind of standardize how these fields are used by documenting it and doing outreach with the people that edit data that aren't ourselves. And then kind of just communicating to them how we want these fields to be used and what we want in them. Another issue we run into a lot, I don't know if it's like this in other states, but in Oregon we really like forks. So a lot of streams are forks of other forks, and we have some very long stream names that we have to try to label on these maps. There's a couple ways around this. One of which is to use abbreviation dictionaries, which we use a lot. So abbreviation dictionaries can, you take a word and then you can have the label engine abbreviate it if there isn't room to draw it. So what's cool about these is that if there's room, it'll put the whole word, but if there isn't, then the label engine will use these dictionaries to abbreviate them. And these are a little small, so I'm not sure you can see them, but the three examples I'm showing here are like our stream layer abbreviations, which are just the cardinal directions in creek. But we have a big one that we use for roads that abbreviates a lot of road names. And then we actually use abbreviation dictionaries also to just remove text. So on the bottom right, these are places that we actually use icons for, like state parks, campgrounds, boat ramps, things like that. We actually use translation abbreviation dictionaries to just remove county park from every one, because the symbol shows you it's that. We don't actually need the text, and that saves us a lot of space. But sometimes these forks of forks of forks are very small streams that we don't really care about anyway. So when we run out of room, we just do an exception query and just say, don't draw these ones. That's too much. Another challenge that we run into is just all of these overlying features and where the label engine wants to put them. So in this case, this stream is actually southwest of this lake, but you know, the label engine says, but Carl, there's this really nice open space right here that's just perfect for labeling this stream. And we do have a default label weight that we use, or feature weight that we use, basically saying, try not to label over water bodies if you can. And so label weights go up to, or feature weights go up to 1,000 as the max. Our default is 800, but sometimes you have to fudge with this a little bit. And in this case, if you kick up the interior feature weight to 1,000, the label engine is finally like, all right, fine, I'll put it over here where it belongs on the stream itself. Another thing that's a lot more straightforward to do with annotation that we had to figure out is highway symbols. So we have, you know, county, state, interstate, all use different shields. And it's pretty easy to deal with these with annotation, but we have to do some tricks to get it to work with our labels. And this is where those prefixes come in our road number field. So we actually use these prefixes and then use a SQL query to create or put these into a different label class that uses a call out that puts the number that follows the prefix into the symbol and then draws it dynamically on the map. So we have different prefixes for all the different road symbols that we use. So it's the only thing that we allow to be in the road number field that's not a number. We also just run into the limits of the label engine sometimes. And in these cases, the ones on the bottom, these are roads that mostly run north-south, but the label engine has just kind of thrown up its hands and said, sorry, I'm just going to put this flat because I have no idea what to do with these. And in the top one, it's actually compressed the label beyond what we tell it is allowed. And so we have some rules on these labels that says you can go down to this font size, but you can't go any lower, and you can compress it 10%, but don't do more than that. The one on the top is more than 10%. I don't know why it does this. If anybody from Esri has some insight on this, I would love to know. But some ways around this is we actually create a separate label class that we call cartographic exceptions that we use a SQL query to pull out and dump into this. And we allow them to bend the rules a little further than what we actually want to get them to draw in the right place. And what's a little baffling to me is that in the case of this, the bottom right, where there's these labels that just draw flat, we say, okay, you're allowed to go down to 4-point font if it helps you put it in the right place. It makes the software put them in the right place, but it doesn't actually reduce the font. I don't know why this works, but it works. And so that's cool with me. So we really like using labels on our maps. Even though it has its challenges, we really like the advantages that it provides us. One of those just being that it's more flexible. We can use them for maps with different scales. They draw dynamically on the maps. We can use these for our base map products like vector tile packages that aren't compatible with annotation. In theory, these make future map updates easier, so the next time we update one of these maps, if the underlying data has been edited, we open it and the labels will refresh in the correct way. But a big one is we used to spend hours and hours and hours placing annotation and moving it and figuring out what road names have changed by reviews with our field staff. And now we're actually improving our underlying data, which is really cool. So this is the part of the talk that I admit to using annotation still. And there's a few places where we do that. There's things like, Pacific Ocean. I'm pretty sure that name's going to stick, and it's not going anywhere, hopefully. So we use graphics for things like that, just because it's a lot more straightforward, and you can kind of put it exactly where you want it. Same for one of the maps we're working on now has the Columbia River Gorge National Scenic Area, and we kind of want to be able to put those where we want. And then in things like physical features where we want them to run a certain way, like on this left image, we use those as graphics and annotation. And then I mentioned being able to layer some of the labels under data. We have township labels for navigation, but we want them to draw under the other features because they're really big and would kind of make a mess. So we still use annotation for those so we can actually layer them under the features. Hopefully I have time for some questions. Here's some QR codes to some of our websites. We have a GIS hub site where we have data and maps available. We have a web application where you can download georeference PDFs of all of our protection maps. And then I mentioned that we have a base map version of these protection maps, and that can be found in our AGOL on the right. Thanks. If I don't get to your question, please reach out via email or find me at the conference. Thank you.
All right, let's maybe do 1 or 2 questions. Does anyone have a question? Over there.
Hi, so great talk. I'm a little bit curious about how, once you have this finished product with so many different types of labels and all over the map, what your process is for checking them for legibility and checking to see whether you like where the label engine has placed them.
There's nothing fancy. We print them out, or sometimes we just make PDFs and we go through township by township and make sure. So we have all these kind of middle ground products that we go through, and we call it mowing the lawn. You just go through and you just make sure everything's drawing in the right place. We circle all the ones that are wrong and then go through and fix them. And sometimes you fix some and it screws up others, and you just kind of mess with it until it all looks good.
Got it.
And even then, after we print them, as soon as I get that printed copy in my hand, I find things that don't look very good, and then we have to fix it next time.
Thanks.
Thank you.
Then you have to go in with a weed whacker.
Yeah.